Continue with this lesson here, 2.1. I'll be able to explore how magma and sediment form by using the rock transformation simulation. That should already be copied down into your notes. So let's continue with this, right? So we did the warm-up together. We wrote down the chapter 2 question. Just to review once again, claim 1 to answer the chapter 2 question, which states, where did the magma and sediment that form the rock of the Great Plains and Rocky Mountains come from? Claim 1, right? We know that one has to be older than the other. The sediment that formed the Great Plains came from the rock of the Rocky Mountains. So the Rocky Mountains here are older than the Great Plains, right? Because it came from the Rocky Mountains. Claim 2, the magma that formed the Rocky Mountains came from the rock of the Great Plains. That states that the Great Plains are older than the Rocky Mountains. So we just got to figure out which one, in fact, is oldest and where the rock originated from. All right, we worked on this activity. This should be in your notes already, what causes sediment and magma to form. And you started working on this in class. All right. I think we're up to this point. All right, so right now, take a few minutes and let's get to the sim. All right. All right, click on rock transformations, and what you need to do is we want the energy mode. So click on these 3 horizontal bars, click on energy mode, and hit yes. All right. All right, got it, good. And you have your toggles, right? We have sun and Earth's interior, so I'll just click on the sun. You guys can observe. If you want to do this yourself, you can do this yourself. It kind of does a lot of things for you, right? So you're just observing. All right. So the model has ended for this energy source. Turn on another source to continue and select Analyze Rocks to restart. Okay. So let's go with Earth's interior. All right, so everything has ended here. Analyze rocks. So we see a lot of sequencing of sedimentary here. We have sediments. We have some metamorphic rocks happening here. All right, that's metamorphic rock there, metamorphic here. We had original igneous. We have the mantle. We have igneous rock there, right? The original igneous rock, right? As the plates were moving. Okay. All right, let's work on this together. Make sure you have this open and you're ready to go. All right, so we did one together yesterday. Let's go to page number 2, right? On page number 2. Okay. So when you work on this, I saw magma being formed when? All right, so magma was formed inside the earth, right? We saw that in the mantle, and it has to be from the interior of the earth, inside the earth, all that heat energy. I saw sediment being formed when blank was turned on. Sediment was formed, we saw that flowing downhill because of the weather, and that's because of energy from the sun exposed at the surface. Sun needs to evaporate the water, and evaporation leads to water vapor in the atmosphere. What new rock formations did you see when the landscape was exposed to energy from the Earth's interior? All right, so rock formations, Earth's interior. We saw the magma that came up and it formed different forms of rock. Right, so you should know that this would form, right, igneous rock. So the rock formations I observed were in the form of igneous rocks. All right, and then what new rock formations did you see when the landscape was only exposed to energy from the sun? All right, so the rock formations I observed were in the form of. Now we saw sediments being made and flowing downhill, and it went into a basin called the ocean, right? Or it could be a lake. We're not too sure, right? All right, and then this type of rock is called sedimentary, right? And it formed in the ocean. Okay. All right, let's continue with this lesson. All right, please get this down in your notes. Energy, right? Energy, the ability to make things move or change. Energy, the ability to make things move or change. We have had energy before in unit number 2 for cellular respiration and for phase changes, right? Phase changes would need energy transferred in or energy transferred out. All right, so same definition in a few units already. All right, next vocab term is weathering, the process of rock breaking down into smaller pieces due to wind or moving water. And we need to add some material here. So put a comma here in between wind and water, and let's add the following words to it. All right, big blocks of ice. Let's add glaciers. Let's add the rock falls and the rock slides and the avalanches called landslides. And let's add one more. In the summertime, you guys love to go there to the beach going to add ocean waves. Add these three to your definition. So it should say the process of rock breaking down into smaller pieces due to wind, comma, moving water, comma, glaciers, comma, landslides, comma, ocean waves. If you want to just add maybe and ocean waves. All right, next vocab term, erosion. The movement of sediment from one place to another, often caused by wind, comma, flowing water, comma, and I need you to add glaciers, comma, landslides, comma, and ocean waves. All right, once again, the movement of sediment from one place to another, often caused by wind, comma, flowing water, comma, glaciers, comma, landslides, comma, and ocean waves. All right, let's check out this video dealing with the process of weathering.
Looking at rocky landforms, you might think they've always been the same, but they're actually always changing. These rolling hills were once very different. Millions of years ago, they were jagged peaks.
All right, so millions of years ago, they were much higher, right? Now they're lower. That is the process of breaking down, right? These big rock formations were weathered and eroded. Look at the very tops of these. These are capped by snow, and a lot of snowfall can eventually make ice. It makes glacial ice happen, right? And that can help weather and erode these rock formations away.
The surface of Earth is constantly transformed by a process called weathering, where energy from the sun causes rock to break down into smaller and smaller pieces. Where energy from the sun causes rock...
Okay, this here, right, if this was the biggest piece of sediment, right, you should know what that is, right? This could be a boulder. If this was the smallest piece of sediment, what can that be? And the answer is a piece of clay, right? But this is a piece of sediment. Not too sure what size it is, not sure on the scale.
Rock to break down into smaller and smaller pieces. But the sun doesn't melt or break the rock directly. The process is more complicated than that. The sun's energy warms the ocean, and liquid water evaporates and...
Okay, so vapor, we should know that vapor is in the gaseous form or gaseous phase. And as that gas rises in the atmosphere, and eventually it's going to cool down. If you remember back to unit number 3 on phase changes, some of you read about and then you discussed this with your classmates on slot canyons, flash flooding, right? Slot canyons and flash flooding would have to happen because we need the liquid to turn into gas, right? And then the gas turning back into liquid in the form of condensation. I'll talk to you in a second. And then we have the formation of clouds.
Into water vapor in the air. Then the water vapor condenses into clouds and falls as rain or snow. Energy from the sun also warms the atmosphere, making air move around as wind. Together.
All right, so initially that rain was over the ocean, right? And it's being pushed by wind. So that rain can eventually make it to land and help out with the weathering process even more.
Snow. Energy from the sun also warms the atmosphere, making
Wind's
air
gonna push
move
it
around as wind.
onto
Together,
the land.
the moving water and air interact with Earth's
Weather
surface,
the rocks.
causing weathering. Here are some examples of how this can happen. Wind can blow small rock particles over landforms, slowly wearing down the rock. In the mountains, frozen water falls as snow
glaciers.
and forms glaciers that are like huge rivers of ice. The ice grinds against mountain rock, slowly carving valleys.
Weathering right here, breaking off.
Water from rain and melting snow forms fast-moving rivers. River water bounces rocks around, causing them to bump into each other and break into smaller and smaller pieces. Through this process, giant boulders can break down into tiny pieces of sand. Broken down rock is called sediment. Sediment is moved around by the same wind and water that created it. This process of moving sediment is called erosion. Erosion happens in many ways. Rivers can move sediments downstream. Wind can blow sediment to a new location. And rain can cause landslides that move sediment downhill. Now you know how energy from the sun causes weathering and erosion on Earth.
At least the surface. Okay. All right. All right, I broke down that video for you. Let's look at this here. It says cave in Shasta Caverns Formation, Lake Shasta, California. Now, we have caves and caverns all over the United States, right? So this is a cavity that developed. This was one big rock formation, and because water gets into the earth, this can also begin to weather some of this rock inside the earth, giving you these cavities. Now, if these cavities become big enough, right, they can form sinkholes. So that is, sinkholes is when a lot of these have been collapsed. Let's go with sinkhole depressions. Okay. So if you notice that there's still some dirt inside here, so it hasn't fully collapsed in, along with this one, right? This one here there's now a depression here, right, in which the land almost cannot be supported anymore. Same thing with this picture. And once it cannot be supported, that's when you can get these massive sinkholes in which they can go down pretty deep into the earth. All right, sorting rock processes. All right, let's go over this digital tool. Right, let's do this together. Make sure this is up on your screen. All right, so click on this link. That'll take you to a modeling tool. All right, so if we're gonna drag this over, we have three options here to choose from, right? So we have weathering and melting. Now, according to the sim, we notice that whenever you hit melt, it has to form in the mantle. So we're gonna drag this to the mantle. And is this energy from the Earth's interior or energy from the sun? Right, by now you should realize that this is occurring from energy from the Earth's interior. Weathering, now we have two portions here. We have the surface and we have the outer layer of the Earth here too. So where exactly do we have the weathering happening? Where we have exposure, right? And the fullest exposure is not going to be below the surface, it's going to be at the surface. All right, and then we should definitely, which one should we choose here? Energy from the interior or energy from the sun? At the surface, right, the sun is going to be the main culprit of the weathering process at the surface, right? And that should be your modeling tool. All right, ladies and gents, thank you so much for paying attention and working your way through this lesson. All right, for those of you who are done, if you want to jump ahead a little bit, you can click on Rock Transformations, go to lesson 2.2, right? And if you want to begin, because this is our next lesson, right? If you want to begin the reading of Devil's Tower, you can click on Activity 2 and click on Devil's Tower, and you can begin reading and annotating this article. Right, you need at least one red with a question, one yellow with an interesting point, and at least one green with a note as well. All right, thank you and have a great day.